All right, so here is part 2 of our notes for today. We're going to talk about a square. And even though a square has the most rules slash facts, most people like squares better because anything you can think of work with the square. So the cool thing about a square is it has all the properties of a parallelogram. So these 5 right here: opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles supplementary, diagonals bisecting each other. It also has the 2 special properties of a rectangle, which are right here. Okay. Has 4 right angles, and your diagonals are congruent. And then you'll see it also has the 3 that we just talked about for a rhombus. 4 congruent sides, diagonals are perpendicular, and diagonals bisect each other. So a square has every one of our properties that we've studied and looked at so far. So we like squares because anything you can think of that we used works. So we're going to approach these the same way. We're going to take what we know, fill in what we have, and then see what we can do with the answers. So let's just start with the sides. They tell me AD is 11, so put 11 there. So what do we know about the 4 sides of a square? Well, it's just like a rhombus, 4 congruent sides. So if that side is 11, we know the top is 11, the right is 11, and the bottom is 11. They also tell me that AE is 8, so I'm going to put that on my picture. So from A to E, that's part of my diagonal. That is 8. Well, what do we know about diagonals? Well, we know from way back when we first started talking about parallelograms, diagonals bisect each other. So if that piece is 8, then we know from E to C is also 8. Now, what do we know from our rectangle? From our rectangle, we know that diagonals are congruent, so we can also use that fact. Well, if our diagonals are congruent, okay, meaning AC is the same measure as DB, okay, if we look, AC would be 16 because 8 plus 8 is 16. That means DB would be 16. But we also know that it bisects, they bisect each other, so we know that this piece would be 8 and this piece would be 8. So it kind of comes apart pretty nicely. Okay? That doesn't happen in a parallelogram or a rhombus. All right, so let's see what they want. They want BC, that's 11. They want AC, again, AC is your whole diagonal, so that would be 8 plus 8, so that would be 16. They want BD, again, it's your whole diagonal. Okay, you can either realize that we already added the 8s, or you can just add the 8s again. That would be 16. And they want EC. And if you look, EC is half of your diagonal right here, and we know half would be 8. Good. All right, now let's erase, because now we're going to look at the angles. And before we go over here and look at the 4 that they want us to write, we're going to fill in every angle on this picture. So the first thing I'm going to do is, because it's a square, and this is something that you guys have known for a long time, probably from 2nd or 3rd grade, I know every angle or every corner in a square is 90 degrees. So I'm going to put my boxes to represent that. Okay, we also get that from the properties of rectangles, right? Rectangles have 4 right angles, so do squares. The second thing I'm going to do is look at and say, okay, well, I have some diagonals here, right? Well, didn't we just learn with a rhombus, which we can use, is that these diagonals, let's just look at one, bisect our angles. Right, bisect means cut in half. So if we know this corner is 90, we can figure out what this piece and this piece is, because all we have to do is take 90 and divide it by 2. 90 divided by 2, 45, because diagonals bisect. Well, doesn't it bisect this angle down here? Well, do we have to redivide? Nope. Okay, I have another diagonal, right? Doesn't it bisect both of those angles, which happen to be 90? So here's why everybody likes squares, because there's not a lot of extra. Okay, diagonals bisect the angles, so 90 divided by 2 gives me 45. All of the angles are 90, so all of the smaller pieces are 45. Here's the other reason people like squares. We also learned from our rhombus that the diagonals, this one and this one, are perpendicular. So what does that mean for these 4 angles in the middle? They're all 90 degrees. So the cool thing about a square is your angles are either going to be 45 or 90 degrees. You just got to look at the right one or figure out which one you're looking at. Okay, that doesn't happen with any of your other shapes, but the way the square is designed, it happens with the square. All right, so let's see what they want. They want DAB, and again, you've got to trace these. Those people getting these wrong is they're not tracing them with their pencil. Okay, so DAB. So D up to A to B, that is the whole entire corner angle. So either you know right off the bat it's a square, so the whole corner is 90, or you could add 45 and 45. Okay, whatever works better for you. Okay. Either way, add or just realize it's 90. All right, AEB. Remember E's in the middle. I kind of wrote all over it. So AEB, A down to E, up to B. You want that angle right there. So we know the angles in the middle are 90. CBD. Again, you just got to trace. C up to B, down to D. And that was not a good trace, but CBD, that would be 45. And BAC. And again, your picture can start looking a little crazy. I'm just going to pick a different color so you can see it a little bit better. B to A to C. There's the angle. It's green. Make it a little bigger so you can see it. It would be this angle right here. And so that is 45 degrees. Okay. All right, so pause the video. We're going to cross this one out right here. It's a little more complicated than what we need. Pause the video and see if you can do this. Do it all. You can start with the sides and with the TR, or you can do the angles. All right, so hopefully you paused it. So again, you start with 17. If that piece is 17, then I know the other piece of the diagonal is 17. Diagonals bisect each other. Okay, we know diagonals are congruent, so this whole diagonal would be 34, which means this diagonal would be 34. Again, if you bisect it, 17, 17. Okay, so we can't do the sides because they didn't tell us one, so let's see what they want. They want PR. Well, we already said your two pieces are 17, so that would be 34. They want QS. Again, that's your whole diagonal, 17 and 17, or you know it's 34. And then they want QT, which is just half of your diagonal, 17. Now we have to look at the angles. So you can fill in the picture or not, but hopefully if you trace them, you can figure out if it's 45 or 90, because those are the only two options. Just make sure you trace it with your pencil. So let's look. PRS. PRS. So it's half of your corner. Good. Be 90 divided by 2, which would be 45. STR. Again, trace it with your pencil. Let's pick a different color so we can see it a little better. STR, S to T to R. What do we know about the 4 angles in the middle? What do our diagonals do? They're perpendicular, which means STR is 90. PSR. Again, trace it. Tracing is your friend with these problems. So what they say, PSR, that is the whole corner bottom angle. You can either say 45 and 45, or it's a square, so you should know it's 90. Oh, I put that in the wrong place. I can't erase. Okay, 90. All right, what about QPR? What about QPR? Let me erase that. QPR, again, I have to trace it too. QPR, it's half of your corner. So 90 divided by 2, 45. Because remember, with the square, it's either going to be 90 or it's going to be 45. Those are the only two numbers that you're going to have to deal with in a square. All right, so if you notice, 8 and 9 go back to rhombus, so you got to be careful with that. But let's look down at 10 and 11, okay? Because since we're still talking about a square, we'll look at 8 and 9 in just a second. So STUV is a square. They're telling us SW, which is half of our diagonal, is 2x plus 13. They're also telling us that WU, the other half, is 8x minus 41. So what do you know about those two pieces? Yeah, they're half of your diagonal. If they're half, then they are equal. So our equation is 2x plus 13 equals 8x minus 41. Okay, then we're going to type it into Desmos, or however you want to do it. Let's see, if we do it by hand, we'd get negative 6 equals negative 54, but most of you just type it into Desmos. So x turns out to be 9. All right, so if x is 9, we're not done because they ask us to find VT. We look, VT. Okay, so don't let them trick you here. VT is the whole diagonal. Okay, remember your diagonals are congruent. So we got to figure out what this piece is, or this piece, and then we have to add them together. So I'm going to do the 2x plus 13. You can do the 8x minus 41. But I'm going to say 2 times, what did we just figure out x was? We just figured out x was 9 plus 13. I'm just plugging it into the 2x plus 13. So that'd be 18 plus 13, so that would be 31. Okay, so this piece right here, the 2x plus 13, we just figured out is 31, we don't know, inches, yards. Now, you can plug into 8x minus 41, 8 times 9 minus 41, but you also probably should be able to skip that because you know if this piece is 31, then you know that this piece is also 31 without plugging in. If you forget that, you can plug in, you'll get 31. But they want VT, which is this whole diagonal. What do we know about the diagonals of a square? They're congruent. So if we know this one, what would SU be? Yeah, 31 plus 31. So VT would also be 31 plus 31, which would be 62. You just got to read and take your time. All right, let's look at this one. If FGHI is a square, solve for x. Okay. Well, they're just giving me half of my corner. What do you know half of the corner in a square is? 45. So you're going to say 7x plus 3 equals 45. Solve it. Okay, again, you can just type it into Desmos, but you should get x equal to 6. And they didn't ask to plug in, they just said solve for x, so we're done, and we move on. Now, there are other ways you could set up this equation, but that's the fastest and the easiest. Again, if you see it a little different, check in with one of us. We'll look at your equation and let you know if you're on the right track. All right, let's look at the rhombus questions. So again, you got to kind of think back, think about what we learned about rhombus. So they're giving me MN and PO. Well, what are those? Yeah, those are opposite sides. What do you guys know about opposite sides? They're congruent. So if they're congruent, you're just going to take 9x minus 77, and you're going to set it equal to, because remember, congruent just means they have the same measure. Find your x. So again, you can type it into Desmos if you need to. So x turns out to be 14. Math right? Let's see, 6, 24. Yeah, 14. Now, again, they didn't ask us for x. They want MP. So I go back to my picture. I figure out where MP is. I say, MP is the side. Well, I don't have anything to plug into for MP. Well, what do you know about all of these sides of your rhombus? They're congruent. So you have a choice. If you want to know MP, you can plug into what they have for MN, or you can plug into what they have for PO, because they're all the same. I'm going to go with the 3x plus 7, because it seems easier. So 3 times, what do we figure out our x was? 14 plus 7. So what, let's see, 3 times 14, 52 plus 7, 59. Okay, so MP is 59. Okay. Now, you could have plugged into 9 times 14 minus 77. That's going to give you 59. But what you just figured out is that side's 59, all your sides are 59. Okay. All your sides are equal. All right, last one. CDEF is a rhombus. Find the measure of FED. Okay, well, FED is way over here. So right now I'm not going to worry about finding that. I know I have to get X first. So now I got to look at what we know about this. Well, they're telling me this piece is 5x plus 1. They're telling me the other piece down here is 8x minus 20. So what kind of equation can we write? What do we know about those two pieces? Remember, your diagonal bisects it. So it cuts this corner in half. So that means this piece is equal to this piece. Okay, remember, if the whole corner is 40, then this piece is 20 and this piece is 20. Okay, we don't have numbers. We just know that this piece is 5x plus 1. And we know the other piece is 8x minus 20. What we do know is that they have to be equal because this cuts that into 2 smaller equal parts. So then we solve, and again, don't make any mistakes. Use Desmos if you need to. You should get 7 for x. Now, we got to figure out how to come all the way over here to FED. Okay, and this one's going to take 2 steps, possibly 3. Because right now, we can't just plug in. Okay, these angles over here are not equal to these angles. Okay, they're not opposite, so we can't do that. But what we can do, since at least we know x is 7, is we can figure out what this angle and this angle are. See if that's going to help us get over to FED. So I can plug in, okay, 5 times 7 plus 1, that would be 36. You can plug in again, 8 times 7 minus 20, but again, if you know this is 36, at this point you should know this is 36. All right, so here's the trick to this one, because this one does have a trick to it. You have to look at the entire corner here at F so that you can get to the entire, because they want the entire corner over here at E. They want FED, so they want this whole thing. So what would the entire corner be if this piece is 36 and this piece is 36? Yeah, this whole angle right here, and again, your picture's going to get a little messy looking, but this whole angle right here is 72, and that's hard to read. So let me take some stuff off my picture. But the whole corner F, let me erase all of this. We know the 2 pieces were 36 because we plugged in, but the whole corner is 72 degrees. So let's put that. The whole corner is 72. Well, now you got to think back to way back when we first started talking about parallelograms last week. What do you know about this entire corner F and this entire corner E? What kind of angles are they? Opposite or consecutive? Angle F and angle E are consecutive angles. What do we know about consecutive angles? Consecutive angles are supplementary, okay, which means they add up to what? 180. So if I know this whole corner is 72, because I did 36 plus 36, then to get the angle FED, which is what they're trying to get me to get, which is that whole corner, then I say they're supplementary. So 180 minus, said that was 72. And so this whole corner is 104. Oh, bad math, right? Back up. It's not 76, is it? I knew that didn't sound right. It's 72, so that's going to change it. 180 minus 72, sorry about that, is 108. So angle FED is 108 degrees. Now, they could have asked you for this piece. You would have divided 108 in half. They could have asked for any of these smaller pieces, but they just wanted this whole corner, so it's the 108. All right, again, if you have any questions, come see one of us, find us, rewatch the video, whatever you need.